Bismillahirrahmanirrahim. Welcome to the third part of the 8th lecture of Statistics and Probability Theory. We will continue with the topic Continuous Random Variable and Continuous Probability Distribution Function or PDF. Example. Suppose that the error in the reaction temperature in centigrades for a controlled laboratory experiment is a continuous random variable x having the probability distribution function f of x is equal to x squared by 3 and its limits are explained or written here -1 less than equal to x less than equal to 2. It means that this particular function is defined only between these two limits. Minimum limit is this and maximum limit is this. Otherwise means the value other than this range will give the answer 0. It means whenever you substitute or integrate or you going to find out the value or this particular function other than this range will give you 0. Verify that f of x is a density function. Part number B, find 0 is less than x less than equal to 1. First of all, we will verify that f of x is a density function. If we want to verify that f of x is a density function or complete probability density function, what we have to do? We just simply have to integrate the whole function on the complete range. All you have to do is integrate the whole function on the complete range. The range starts from -1 to 2 d of x, which should equal to 1. If this condition holds, it means that this function f of x is a density function. Now, we will do the same thing here, -1 to 2, x squared by 3 dx. When we integrate it, what we will get? X squared plus 1 divided by 3 into 2 plus 1. This is the way we integrate the function x squared by 3 with the complete range -1 to 2. What we will do, this 2 plus 1 is 3, 3 into 3 is 9, 1 over 9. So this would be x cube, where function range is -1 to 2, which is equal to 1 over 9. We will substitute the upper limit first, which is 2 raised to power 3 minus -1 raised to power 3, which is equal to 1 over 9 8 plus 1, which is equal to 1. So, it is proved that this is complete density function or a density function as we got the answer 1. So, by this way, we can find out So we can find out here part number B as part number B can be found out by integrating the complete function between 0 and 1. As we know that our function is x cubed by 3, and we have to find out between 0 and 1. This is the limit. We have to find one thing you have to remember, that here we don't have less than sign. It's only less than sign, not equal to sign, and here we have less than equal to. Less than or equal to. In continuous, it doesn't matter we have this equal to sign or not. It will give us same information as this is the continuous case. So by integrating this, we have seen that this would be x4 by, I think it is x square by 2. We have written here wrong. This one is x square. So this one is 3, and by integrating we will get 9, and the range is 0 to 1. So this will give us 1 by 9. We will substitute the upper limit first, minus lower limit. So the answer is 1 by 9. So the area between this particular range is 1 by 9. So here we can have the area between the curve, as if we assume that this is the shape of the curve. Let me assume x square by 3, and this is between minus 1 to, it is minus 1 to 2. So what we are doing here, we are simply finding the area between 0 and 1. So this total area under the curve between 2 points is 1 by 9. This is the way to find the area between 2 points. Here we don't have less than or equal to sign, but if there is equal to sign, we will do it as it is, as we have done in this case. Example number 2. Time headway in a traffic flow is the elapsed time between the time that one car finishes passing a fixed point and the instant that the next car begins to pass that point. Let x is equal to the time headway for two randomly chosen consecutive cars on a freeway during a period of heavy flow. We have a function which is describing this particular scenario, which is 0.15 into e raised to power minus 1.15 x minus 0.5, where x is greater than equal to 0.5. Whenever it is written x is greater than equal to 0.5, or it is written as x is greater than 0.5, it should be same. So if I write this limit, this should be in this type or in this form. X is less than equal to infinity, because it is written here x is greater than equal to 0.5. So it means it is from 0.5 to infinity. The value of the function other than this range is 0. So, and less than 0.5, this function is not defined. So, if we want to find that this function is a density function, what we have to do? We have to integrate it on whole limit. You can find out that in books, this type of problems it is solved in this way, that the limit is described as minus infinity to 0.5 and 0.5 to infinity, because we know that our limit is starting from 0.5 to infinity. So as we are mentioning this minus infinity to infinity, we have just broken it into the range minus infinity to 0.5 and 0.5 to plus infinity. As we know that our function is starting from the 0.5, so there is no such value exists here. It would be 0 as it is written here. That value of this function other than this range or other than this limit is 0. So 0 is mentioned here. Anything which is 0, whenever you integrate it, it will give you nothing. So this part is vanish automatically. Now 0.5 to infinity. So you will integrate it 0 minus 0.515 into x minus 0.15. If you open this bracket, what will happen? This minus 1.5 will 0.15 will go inside the bracket multiplied by this x. This minus minus will come to plus, and 0.15 into 0.5 will lead to 0.075. So it will become a constant. So we will take the constant part outside the integral. So this one is 0.15, 0.075, and you are left with this integral part 0.5 to infinity and e raised to power minus 0.15 into x dx. And when you integrate this, you will get the answer 1. Now, what is the probability that headway is at most 5 seconds? So if you see, the word at most is used here. At most 5. So what we will do? If the shape of the graph is like this, so it starts from 0.5 until go to infinity. We know that, and what it is saying that you have to find out that probability of x is less than equal to 5, because the word at most is used here. So you have to find out this area. 5 will come between 4 and 6. So this is 5, and as it is less than equal to 5, so less than area will come under this range or under this limits, and you can go minimum till 0.5 as your function is defined till 0.5. So you have to find the area between 0.5 and 5 so that you can find the probability at most 5. So how you will find out this? Probability x less than equal to 5. So what we will do? If we start from minus infinity, we will break at 0.5 as our function is starting from 0.5, and as we know this is 0 plus 0.5 0.5 to 5, and our function is 0.5 We'll use eraser here. Right. Our function is, I think it's 0.15. 0.15 into e raised to power 0.75 I think it's 0.075, and if we use the eraser here, good. Now e raised to power minus 0.15 into x. dx. Right? We know this particular part will vanish. You will left with 0.15 into e raised to power 0.5 0.75 integral of 0.5 till 5 e raised to power minus 0.15 into x dx. So by simplifying it, we will get 0.0 0.15 into 0.075. This would be equal to 0 minus 0.15 whole divided by minus 0.5. You have to recall the rules of the integration from the calculus. 0.5 to 5. This is the way to integrate this. Now what we will do, we will simply substitute, here should be x, the values of the random variable x, 5 and 0.5. First we will put maximum limit and then we will put minimum limit. By simplifying this, we will get the answer of the particular problem, which would be equal to 0.491. In this way, you can find out the probability of the particular area or area between 2 points. Similarly, you can find out probability x greater than greater than equal to 5. It means find out the probability at least 5. I'm leaving this topic with this question. How will you find out the probability x greater than equal to 5, a probability of at least 5?